Good morning or afternoon, and welcome to the North Mac High School Algebra 1 EOC video clips. This is clip number 12, objective 4.04, graph and evaluate exponential functions to solve problems. Again, 4.04, graph and evaluate exponential functions to solve problems. Now, as you can see, I have two problems on the board. Problem number one, does y equals 1/2 x represent a growth or a decay? Now, y equals 1/2 to the x is an exponential function. It's an exponential function because x is in the exponent slot. Now, with exponential functions, in order to graph it, you're basically going to use your graphing calculator. You're going to hit y equals. You're going to type in 1, parentheses 1 divided by 2. So you're going to hit y equals. You're going to type in parentheses 1 divided by 2. Close parentheses, up arrow key, x, and you're going to get your graph. Now, 1/2, that graph, 1/2 to the x, that graph represents a decay. What happens with that graph is that when you graph it, if it starts at the top and drops, then that represents a decay. It is dropping. Is coming down. All right. You can also tell that it is a decay because if the number inside the parentheses is less than 1, okay, if b is less than 1, and it also needs to be greater than 0, but for your purposes, if that number is less than 1, then it's a decay. If the number in the parentheses is greater than 1, say that number was 1.03 to the t power, then 1.03 to the t power equals y would be a growth. And the graph of a growth, it starts at the bottom and it rises. It starts from left to right, it starts at the bottom and it rises. It is growing rapidly. Okay, so again, does y equal 1/2 to the x represent a growth or a decay? This is called an exponential function because x is in the exponent slot. If the number in the parentheses is less than 1, then it's a decay. It means that when you graph it, it's going to drop, it's decaying, it's decreasing. It's decreasing, depreciating, okay, meaning that it's going down. If that number inside the parentheses is bigger than 1, then it's increasing. It's a growth. It's growing. Okay? So is this particular example a growth or a decay? It is a decay. The number inside the parentheses is less than 1. All right, number 2. Number 2 is an example of the compound interest formula. Okay, it is the compound interest formula. But the compound interest formula is no more than an exponential growth, or it could be a decay. A is your after amount. P is your original amount of your principal. Parentheses 1 plus, you're going to plug your rate in here, which will be found in your problem. Your rate is your percent. But when you plug a percent in, you're going to put it in as a decimal. Divided by n. This n represents the number of times it's being compounded. That same n goes here and then times your time, which is your years. So again, this P is your original amount. That 1 stays the same, plus the R, that's your rate. This n is the number of times is being compounded. The same number goes here, and T represents time, usually in years. This A is the after amount. All right, so let's look at the problem now. Ron deposited $400, so there's your original amount, $400 into an account with 6% interest. There's your rate. You're going to put it right here, 6% interest. Remember, you never put a percent directly in. You have to change it to a decimal. Compounded monthly, there you go, that's the number of times monthly, there are 12 months in a year, and it says after 6 years, so there's your T. You have everything you need, you just need to plug it in. Alright, so we have A equals, how much money does Ron have at the end of 6 years? A equals the original amount, $400. Parentheses 1 plus. The rate is 6%. Change your percent to a decimal. Drop your percent sign and move the decimal point, which is sitting there, 2 places to the left. So you have 0.06 over. The number of times is monthly, so it's 12. Raise, the whole thing is raised to the 12 times 6 power. 12 times 6 years. Okay? Now, I'm going to bring that down so you can see it a little bit better. So the after amount is equal to 400 times 1 plus 0.06 divided by 12 raised to the 12 times 6 power. 12 times 6 power. All right, now take your calculator and type that in on your calculator so that you can get the correct answer for that. Now you're going to need to type in 400 parentheses 1 plus 0.06 divided by 12, close your parentheses, up arrow key, and then you can do your 12 times 6 and say 72. So say up arrow key 72. Hit enter, and this after amount at the end of 6 years, Ron is going to have $572.82. Okay? So once again, on your calculator, the key sequence is going to look like this. 400 parentheses 1 plus 0.06 divided by 12, up arrow key, parentheses 12 times 6. Okay? Now, that will ensure that you get the correct answer of $572.82. Now remember that this doesn't have to be compounded monthly. It could be compounded quarterly. Quarterly would be a 4 here and a 4 there. Again, a 4 here, a 4 there. It could say semi-annually, which would be twice a year, 2 and 2. So watch that. See how many times it's compounded. Also watch your percent. Make sure you plug your percent in as a decimal. Drop your percent sign or wherever the decimal is, move it 2 places to the left and plug it in as 0.06. If this said 50%, it'd be 0.5. All right, now let me call your attention to this problem. Number 1, you're given the formula again. Immediately now, you should be thinking this is a growth. It's over 1. Now, if I wanted to plug in a t, it says t equals 5. What is y? So I put my 5 in. I can punch it in. Or let's also note that you could use the table function in your calculator. You could type this into y equals, hit table, scroll down to where x corresponds to t, x is equal to 5, get your answer. X is equal to 10, get your answer. Depreciate's formula is the same formula as here, just change your minus, change it from a plus to a minus. And then with this third problem for additional practice, I put in the years problem. Make sure you realize that the years, the original amount is 600,000, parentheses 1 plus 0.02 raised to the, now for your years, you need to subtract. 2020 minus 1970 is roughly 50 years. 50 years. So what you need to do is say up arrow key 50. Make sure that you do in fact subtract those years. Again, 2020 minus 1970 to get the number of years that pass. Now, if you would complete the additional practice and turn it in to your Algebra 1 teacher, they will give you extra credit. Thank you so much and have a beautiful afternoon.